This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be covering what I believe to be my 5 worst mistakes in Python. And these are mistakes that I've made throughout the years, or actually when I started programming in Python, I was quite naive. So hopefully by bringing these up, you can avoid the mistakes that I made in the past. Starting with the very first mistake I made, and that is to perform unreliable or bad benchmarks. Because in Python, there are going to be moments where you want to test whether certain functionality is faster than other functionality. But what I learned a bit later was that timing your code is not as simple as it looks. And I'm just going to paste in an example, and I'm going to explain more as we go through this example. So here I have 2 functions that I want to test for. And what I'm testing for is whether pass is faster or the ellipses is faster. And this is just a hypothetical test. I don't really recommend you care about whether pass is faster than the ellipses or vice versa, but in this example, we're going to pretend that we care about that. Then I'm going to create a function that can time these functions. So here we have a function called getTime, which takes a callable, and then we have a startTime, which uses the performance counter from time. Then we run that function and call that once again so that we can subtract the end time from the start time. And at the end, it's going to say that the function name took this amount of seconds. So here we're testing how long a function takes to run once. Then below that, we can create our if name is equal to main check and try to run these functions. So first I'm going to type in getTime for the ellipses. And since we're calling it inside the getTime function, we should not call the function here. And then we're going to try it with the pass statement. Now, if we were to run this, you'll see that the ellipses took longer in this case. And if we were to run it again, the ellipses still takes longer. This can make it very easy to come to the conclusion that the ellipses is slower than the pass statement. But once again, as I mentioned, there are a lot of factors that come into play when you are trying to time your code. For example, what's happening in the background of your computer can also affect the speed of a test. Also, watch what happens when I change the order of this. So now we have the pass statement above the ellipses. All of a sudden, the tests look a bit different. Now the pass statement takes longer than the ellipses. And once again, that's because this was just not a reliable way to time our code. One thing that we can do to stabilize the results is adding a warm-up. And a lot of you claimed from the last video that you don't really need to warm up your interpreter. I can't really contribute too much to that discussion, but as soon as I add a warm-up statement or some warm-up code, the tests become much more consistent. The first one, of course, takes the longest. It's the first code to run in the script, but then the second 2 just start to normalize and they get closer and closer. Or that's not always true, but they are quite close. So in most cases, I will always provide a warm-up because on my computer, it does something. But there was something else we did incredibly wrong here, and that is performing our test only once. If you have a function that lasts very long or that takes very long, this might be okay. But if you're looking for those kind of micro optimizations, or not really micro, but functions that take milliseconds, you're going to want to use something better, such as a profiler or the timeit module, because these give you much better tools for actually timing your code. So just to sum it up, timing code in Python is not always as straightforward as it looks. Because it's such a high-level language, it makes it just much more difficult to understand what's going on underneath all of this functionality. My biggest recommendation is to always have people double-check your benchmarks, or even post it on Stack Overflow where you can get roasted about your benchmarks. I would treat it as a scientific journal, so document it, have other people try to reproduce the results, and if a lot of people can reproduce the results, then you've got a good benchmark. But otherwise, it's very easy to create biased tests such as this one, so be careful. Moving on to my second biggest mistake in Python, and this has to do with early optimisations. When you first start programming, you get this idea into your head that everything has to be perfect from when you start writing your code. And while that's the ideal scenario, what I learned is that sometimes it's better to create code that gets the job done, rather than code that performs at the speed of light when it doesn't even matter that it performs at the speed of light, because the difference between 20 milliseconds and 18 milliseconds might not even matter in that context. Anyway, suppose you're creating a program and you need to check for a user's age. If you're new to programming, you might end up writing code like this. And this code is perfectly fine, in the sense that it does exactly what you need it to do, so I wouldn't worry about this immediately. I would continue working on making sure that the program can actually function. And then with experience, you might be able to change this with a much easier implementation, which obviously is just returning if the age is more than equal to 21, rather than returning true or false, which is always considered to be a noob move. But regardless of how silly this looks, I would still continue working on the rest of the program before trying to fix it. And I probably wouldn't even care about timing this, because learning simple tricks like this just comes with practice. For me, it's quite obvious that I should have done this from the start, but in this simple example, it might not have been so obvious for a lot of people. But now I'm going to show you a much better example of optimizing your code, or prematurely optimizing your code. So in this example, we have a function that calculates the sum up until n. And the way we're going to do it is first by creating a variable called result. Then for I in range n, we're going to add I to the result each time. So we're gradually adding those numbers together. And then we're going to return the result. In this case, this was the most readable and most straightforward approach to creating this function. And if we wanted to test it out, you'll see that it works just fine. If we're calculating the sum of 10, we're going to get 45 back. But while this was incredibly straightforward, it is not the optimized approach. And if you insert a huge number, this can take ages to calculate. But once again, it gets the job done. And supposing that we're not ever going to insert those huge numbers, it's probably just fine. Later on in our program, if we decide that it's too slow, we can always go back and optimize it using the arithmetic series formula. So this is going to perform the exact same operation as this, or it's going to give us the same result at least. And we can verify that by printing calculate sum optimized and passing in 10. What we should get back is 45. And as you could see, if we inserted a number such as 10, we get the result back instantly, and that's fine for both of these cases. But now I'm going to bring in my getTime function, except this time I also decided to include arguments because we need to pass in some arguments to our function, and we're going to time both of these functions. So first I'm going to start with our if name is equal to main check, and then I'm going to get the time for the calculate sum, and I'm going to pass in 10. And I'll do the same thing for calculate sum optimized. And if we were to run this, they're both going to give us back 0 seconds because they are both very fast with small numbers. But now watch what happens when I insert 1 million. You'll notice that the original implementation took significantly longer. It was instant, but not as instant as calculate sum optimized. And even worse, if we were to change this to 10 million, you'll start to see the effects of how slow, or actually it wasn't that slow with 10 million, so we're going to change that to 100 million. And now it starts to delay. The original one took 3 seconds, with a huge number such as 100 million, while the optimized version still took no time. And if we were to comment that out, you'll see that this one is instant, while the non-optimized version took 3 seconds. So all I wanted to say here is that sure, it might be cool to optimize your code from the get-go, but in many cases, it's going to be much better to have a program that actually works rather than wasting hours to optimize your code so it works at peak performance. And how fast you want a function to actually work always depends on your use case. If you're running a script once a day, you might be fine with waiting 3 seconds. Otherwise, if you're running your script thousands of times per day, eventually you might want to optimize those snippets of code. Or also if you know that the number is going to exceed, let's say 100,000. At a certain point, you're going to understand that the original implementation just doesn't suffice, so you can optimize it. But doing it from day one can really ruin your productivity. Up next, we have the third biggest mistake that I've made in Python. And this goes back to when I first started using Python several years ago. I wrote all of my code without type annotations because I just came from Java and Swift, and I was incredibly happy that I could finally ignore those things. But after coding for a while, I realized that I make a lot of mistakes. I am human and I recognize that when I'm tired or when I'm not paying attention, I'm going to make a silly mistake, which can be really tough to catch later. So about a year ago or maybe 2 years ago, I decided that I'm always going to annotate all my code. Even if it's a simple data type, it still saves me the trouble from making silly mistakes. For example, you might have a name of type string, which is obviously Bob, and then you might have an age of type integer, which in this case we're going to set to 100. Now, if you have a static type checker or a modern code editor, you're probably going to see some squiggly lines that tell you that you're assigning the wrong data type to the variable. And if we hover over it, you'll see MyPy will even complain that we expected an integer, but we got a string instead. And that's really good because when I'm tired, this might have accidentally happened. I know it looks quite silly that it could happen with a basic data type such as an integer, but it does happen. And without this type annotation, I would look at this and I would think, yeah, that looks about right to me. I mean, when you're tired, you do not see these things. So we get no warning from the editor that we did something that we did not want to do. Age is inferred as a string. Python works just fine. Nothing's going to crash here. And then later on in our program, we'll use that age as if it was an integer, and it might or might not work. But I much prefer the certainty of knowing exactly what I'm doing. So I'm going to change that to integer, and then we can just pass in Bob's age, which is obviously 1209. And type annotations also help with context actions, which can also make it much easier to develop code. But just a quick disclaimer, if you are editing your code in Notepad or in Vim without additional plugins, you're probably not going to get any of the benefits of type annotations. But I haven't tried to use Vim or Notepad to code, so do let me know if you would use type annotations there or not, or whether it's completely useless. But in modern code editors, it brings you a lot of benefits. Or I actually take that back, because with Notepad or Vim, you can run a static type checker to check whether all your types are what they should be. But I really like when I see squiggly lines in my project, or I don't really like it, but I'm happy that it does warn me. Anyway, going back to the function here, we're going to create one that says fire employee. And that's going to take a name of type string, and it will return none because we are just executing code here. Now, if we were to type in print the f string of name.capitalize, you'll see that we're going to get the context actions for a string. Without this string type annotation, Python's going to have no idea what name could be. Or that's not completely accurate. Our code editor is going to have a hard time inferring what name actually is because we have no information regarding it here. So we're not going to get those context actions. So here I'm going to say that it's of type string, and we're going to capitalize name in case it's not capitalized. And of course, we're going to type in you are fired. Now I'm going to create my if name is equal to main check, take these global variables and put them inside our main block. And just like that, we can now use our fire employee function, and it's going to safeguard, or it's going to warn us if we put in a data type that we should not, such as, let's say, I don't know, we can pass in 100. Here we're going to get those squiggly lines. Or if you run MyPy, it's also going to give you some more details regarding this error. Otherwise, if we were to fire an employee called Bob, and we can just actually pass a name here, this will work just fine because it's of the correct type. It's of type string. And this is going to crash the program, so I'll remove that. But now if we were to run this, you'll see that Bob, you are fired. Otherwise, if we were to pass in that incorrect type of integer, our program's not going to be able to process that because int has no attribute capitalize, which is the first operation we perform in our function. So obviously this is not going to work, and getting a warning that that's not going to work is lovely. Although I did notice that recently in PyCharm, it looks like they had an update which still warns us even if we do not pass in the data type. So here it says type int doesn't have that expected attribute, which is quite cool. I think it's cool that PyCharm can infer that by seeing how it was used within the function. But before we wouldn't even get a warning here because name has no information, which means we can literally pass in any data type we want, and that would be acceptable. So defining it to be of type string is just much more specific and self-documents the function a little bit. But type annotations get much more complex than this. And if you're curious about the benefits of type annotations and how to use them much more professionally, I have a full course on this, which you can find on my website. I'm going to leave a link to it in the description box down below, just in case you're curious. Moving on to my fourth biggest mistake. And in this example, I created a module for Bob, which is called Bob's module. And inside Bob's module, we have a few functions. One is called getDescription, which returns a description of Bob's module. And the next one's called getName, which returns the name of Bob. And we also have a function which returns to us a random Bob. And here I have 4 options that we can return, and I use random.choice to pick a random option. And obviously, while I'm developing this script or this module, I want to test the functionality. So down at the bottom, I would print all of these. And if we were to run this, you'll see that all of it works just fine. We get Bob's name when we use getName, we get the description when we use the description, and we get a random Bob, which changes each time we run the script. So next I'm going to go to main and I'm going to import Bob's module as Bob. And then we can paste in all that functionality. We have random Bob, getDescription, and getName. And if we were to run this, what you should notice is an output such as this one. Otherwise, we can also print something else like hello world. And you'll see that that doesn't work. And this is one of the biggest mistakes I still make today. And that is running the wrong script. And no matter how many times I change this, it's not going to affect this because obviously I'm still running Bob's module. And in a very short moment, I'm going to show you my solution to not making this mistake anymore. But just for now, let's pretend we remembered that we need to change the script, right click on main and run main. Now we have the second problem. We have a double output. And that's because when we import Bob's module, we actually run all of the code inside Bob's module, which means our test at the bottom also got run. So a very important addition I always use in all of my scripts is the main entry point. And the main entry point is actually quite optional. It's good for encapsulating your code and excluding it from the global scope. But what's really important for your scripts is the if name is equal to main, because this will check that we're running the script directly before executing this functionality. So if we're to copy and paste this inside main and go back to our main file, you'll see that we will only get the output from within main.py because Bob's module was not run directly. If we were to run Bob's module directly, this time it will run the code from within here. And to make that more obvious, I'm going to also print Bob's module at the top. And as you can see, we get Bob's module executed. But another great benefit of doing this is that in most modern code editors, you get this green play arrow next to the script or in the script that you're currently looking at. So instead of using the shortcut, one thing I'll usually do is tap on this green arrow just to ensure I'm actually running the correct script. And if we go to main.py, we can do the exact same thing. We can create our if name is equal to main check and paste in the code that we want to run. Now, if you're using PyCharm, you're probably not going to have this shortcut. If you type in main, you're only going to get the if name is equal to main check. The reason I get also this main block here is because I went into a setting called live templates and I created my own live template, which means that I also get this shortcut when I type in main. Anyway, now that we have all of this, we can tap on that green arrow, and that's going to ensure that we're actually running the correct script. And that's why I always highly encourage you to use if name is equal to main. It helps prevent random code from being executed from other modules, because once again, as soon as you import a module, all of this gets run. And if you're testing anything, you obviously do not want that test to get executed while you're importing it into a real project. Otherwise, an added benefit is that you get this silly green arrow that allows you to make sure that you're running the correct script. And finally, the last mistake I always make, and this is mostly due to being just lazy, is not planning out my projects before I actually try to build them. When you want to create a website or some sort of product, in general, you'll create a sketch that contains what you want your project or your product to look like. And in general, this is a great idea because it saves you a lot of time and effort when it comes to figuring out what you actually need to do to make this program or a product function. So if you have a piece of paper, I absolutely recommend that you try to plan your project before you actually write the code. Or if you don't have pen and paper, of course, you can also try to plan it inside a script. For example, imagine we're creating a lamp or a smart lamp. So here I have a class called smart lamp. And right now, the only thing I did here is create an initializer that takes a name and a version. And obviously it might make sense to type in all the functionality as we create it, but a better alternative is to actually just create that blueprint. Here I created all of the possible options that a lamp should have, such as being able to turn itself on or turn itself off, or to check for updates. But I did not implement any of that code. I just created this blueprint for what my smart lamp should look like, so I wouldn't forget later what I would have to include when writing the code. This makes it much easier to plan how our lamp should look like, which in turn is going to make it much faster to program. And obviously this is a very simple class. There's only 3 functions or 3 methods that we need to make this lamp work. So for much bigger projects, this can be even more beneficial, because there's nothing worse than forgetting a very important piece of functionality for your project. And again, this can save you from a lot of trouble, because now you know exactly what the end product should look like. Meaning that once you have all of this, you can just start typing the code without having to think what's missing. Now, obviously this isn't foolproof, so you are going to probably miss some functionality here and there because errors do arise. Unexpected functionality does come up. That's just how things are, and you'll get used to it. But having a blueprint of what you should be making just makes the development process much more smooth. But yeah, obviously I don't do this all of the time because I'm a very, very silly guy, but I really should. And yeah, that just about concludes the 5 biggest mistakes that I make in Python. Most of these are very straightforward and don't really take that much time to learn. But as always, I would really love to hear what your mistakes were when you were learning Python, or which mistakes you recently came across that you wish you learned earlier, or which you're very happy you learned about recently. And yeah, with all that being said, as always, thanks for watching, and I'll see you in the next video.